In question 3 of this series, where we graph a cubic function, we end off with our hardest function to sketch, and it's shown right here. F of x is equal to negative x cubed plus 3x plus 2. And just like in question number 1 and 2, we have to first factor it, find the zeros, the domain and range, and then eventually sketch. Now the reason why this question has been given a difficulty rating of hard is because you need to use a special theorem known as the rational zero theorem. It's defined below and it goes a little bit like this. Notice that our function isn't factorable the way it was in question number 2. Now of course you can factor out something between this term and this term, but that's not going to help. Instead, what you have to do is analyze the coefficient of the x to the power of 3 term and the constant. So for this term we have a leading coefficient of negative 1, I'll write that down, and the constant is 2. And what you have to do is find multiples of negative 1 and 2. Let's go ahead and do that. What multiplies to make negative 1? Well, you have negative 1 times 1, and you have 1 times negative 1. Therefore, plus minus 1 are numbers that multiply to give you negative 1. And similarly, what are numbers or multiples that multiply to 2? You have 2 times 1, negative 2 times negative 1, and that can be summarized as plus minus 2 and plus minus 1. So next what you do is you take these numbers, plus minus 2 and plus minus 1, and you divide them with the multiples of the leading coefficient, plus minus 1. And eventually you should end up with the numbers plus minus 2 and plus minus 1. So all the quotients that you would get dividing these numbers out would give you plus minus 1, plus minus 2. Now the reason why these numbers are important is because now we can use these numbers to perform synthetic division using the coefficients of all of the terms. And here's what I mean by that. So the coefficient here is negative 1. We don't have an x squared term or a second degree term, so we'll say it's 0. Over here the leading coefficient is 3, and over here the leading coefficient is 2. So what I will do is take negative 2, positive 2, negative 1, and positive 1, and perform synthetic division with the numbers negative 1, 0, 3, and 2. And the same thing for positive 2 and plus 1 and negative 1. And if you're wondering, the reason why we're performing this synthetic division is we want to find out which of these will give us a remainder of 0. And it turns out that the one that gives you a remainder of 0 is the number that is a root of the function. So here we go. The way we do it is we first take this negative 1 and place it at the bottom. Essentially we're adding negative 1 to 0. Now we take negative 2 times negative 1, that's positive 2. Place that right here. 0 plus 2 is 2. Negative 2 times 2 is negative 4, and 3 plus negative 4 is negative 1. Lastly, negative 2 times negative 1 is positive 2, and adding 2 and 2 together is 4. The last number we end up with is positive 4. It's not 0, so negative 2 doesn't work. Let's test positive 2. Once again, we'll bring this negative 1 down. 2 times negative 1 is negative 2. 0 plus negative 2 is negative 2. 2 times negative 2 is negative 4. Adding these two up, we end up with negative 1. Multiplying 2 and negative 1 is negative 2, and adding 2 and negative 2 is 0. We end up with a remainder of 0, so this is one of our roots. Now without having to test these, you will not end up with the roots of 0. So to save time, I'll skip these. So what do we do with this positive 2? Well, the way you write this is you write it as a factor. So f of x is now equal to x minus 2. You're placing this into, let's say, x minus a constant. So if you place a positive number into here, you end up with x minus 2. Just keep that in mind for future reference. And this is being multiplied to a factor where these numbers represent the leading coefficient of an expression that's of second degree. So we have negative x squared, negative 2x, and negative 1 as the constant. We can now go ahead and find the zeros by setting f of x equal to 0. So we'll rewrite this, and this expression is a quadratic. In fact, you can factor out a negative 1 let's make it easier for ourselves. It becomes x squared plus 2x plus 1. And this can be factored by trial and error. What two numbers multiply to 1 and add to positive 2? Those two numbers are positive 1 and positive 1. So we have negative x minus 2, and I'm going to break this down into x plus 1 squared. Having set this equal to 0, we end up with two x-intercepts. An x-intercept at x is equal to 2, and an x-intercept at x is equal to negative 1. And of course, these can be written as points. So we have a point at 2 and 0, and a point at negative 1 and 0. Plotting these, we'll have a point. Let's say that this right here represents positive 2, that's positive 1. We'll have a point right here, and a point right here. That's negative 1 and 0. They also want us to find out the domain and range, and without going into too much detail, anything you put into x, you'll get an output. So your domain consists of all real numbers, and your range is the same. In D, we're asked, use the y-intercept, x-intercepts, and other properties of the function to graph. To find the y-intercept, I'll set x equal to 0, and you should end up with a point at 0 and 2. That's the y-intercept. And just like we learned in questions 1 and 2, if this is negative, your function, let's say we have an xy plane, your function will start in the second quadrant, so your curve will go like this and make its way down to the fourth. If this is positive, the opposite is true, it goes this way. So keep that in mind when we graph. Let's start by plotting 0 and positive 2. It's over here. It will start somewhere here, then make its way up through this point, and we're done. So starting up here, it'll pass through this intercept, and then make its way through here, reach a maximum. And the reason why I knew it goes up and doesn't dip down came from pure speculation. Of course, you can use a table to have test points between negative 1 and 0 to see what happens immediately after it reaches this x point. After this, it'll reach a maximum and go through this point and continue on downwards. And there you have it. That is how to graph a cubic function without a calculator.